this video, I'm going to continue the chapter 12 and 13 recap and go over double replacement or displacement, whatever you want to call them, reactions, because these reactions will be coming up later this week. So double replacement reaction is when you have two compounds and they react with each other and pretty much they swap with each other. So here's another way to look at it. If A, B, C, and D are each different elements or polyatomic ions, and we're going to have the cations, which are the positively charged ions, which are the metals, switch with each other. That's how I always approach these, is I just switch the first element or polyatomic ion with each other. And with these types of reactions, you will be provided the reactants, and they will also be balanced as well. So we're going to start with switching the Mg and the Na, which are both metals, and they're both positively charged ions. So we're going to switch those with each other. And before I write the final answer, I'm going to just show my work down here. So the Na is now going to be with the Cl, and the Mg is now going to be with the OH, which is a polyatomic ion. So that's the first thing you're going to do, is just write what elements or polyatomic ions go together. The second thing you're going to do is make sure that you write the formula correctly. This is one of the most critical and important parts. And these are ionic compounds, so in order to figure out how to write the correct formula, you can figure out the charges and then do the crisscross. So we'll start here. So we have sodium and chlorine, which we know that that's sodium chloride, which is salt, but I'm still going to walk you through the steps. So sodium is right here. It is in group 1, so it would have a charge of +1. Chlorine is over here on the right-hand side. It is in group 17, and it has a charge of -1. So if this has a charge of +1, this has a charge of -1. If I go to do the crisscross, again, the crisscross, this is just a shortcut to figure out how to write the formula correctly. So what happens is that the number, not the charge, becomes the subscript for the other element. So since these are both ones, we don't have to write them because we don't write the ones. So the formula would simply just be NaCl. Okay. Now we have our second compound, which is magnesium and OH, which is hydroxide. So magnesium is right here. It's in group 2, so it's going to have a charge of +2. And then OH, this is a polyatomic ion. This is going to be on the back of your periodic table, and this is going to have a charge of -1. And again, I just do the crisscross simply because it's a shortcut to figuring out how to write the formula correctly. Because in reality, when we write this formula, we need the charges to be balanced. So for example, if you have magnesium that has a charge of +2, you're going to need 2 OHs because each of those have a charge of -1. So then that would be -2, which would balance out with the +2. So that's one way that you can approach this, but I definitely find the crisscross a lot easier. Another important thing to remember is when you are working with those polyatomic ions, don't forget the parentheses. So again, I'm going to put the 1 here, so the magnesium is going to have the 1 as the subscript, but again, we don't write the 1s. And then the OH, this 2 is going to become a subscript for the OH. Now you cannot write it like this because then that's implying that the hydrogen is only being applied, the 2 is only being applied to the hydrogen. So you have to make sure that you put the parentheses around the OH and you put the 2 on the outside. This would be the correct way to write that formula. So this would be MgOH2. Another thing that we're going to have to do is balance this equation. Now, remember that the left-hand side will already be balanced for you, so you only have to balance the products on the right-hand side. So let's start with sodium because that's the first one. So you're going to notice that there is a 2 in front of the NaOH on the left-hand side. So that 2 is being applied to both the sodium and the OH. So in order to have it balanced on this side, we're going to have to put a 2 in the front here. And that actually works out because the 2 is being applied to the Na, but it's also being applied to the Cl, which is the chlorine. And on this side, you're going to notice there's 2 chlorines. So that means that the sodium, the Na, and the chlorine, the Cl, are both balanced. Next, we're going to move on to the magnesium. So there's 1 magnesium on this side and there's 1 magnesium on this side. Good, those are balanced. You're going to notice that there's 2 OHs on this side here. And on this side, we already have 2 OHs because that 2 is being applied to the OH. The number in the front, this is called the coefficient. This gets applied to everything that it is in front of. And then the last piece that I'm going to add to this is what you're going to see later this week. So you're going to notice on the left-hand side here, these were aqueous because, well, according to our chart here, both of those compounds are soluble and therefore aqueous. So now we're actually going to figure out, are these two, are they soluble and aqueous, or are they insoluble and will form a solid precipitate? So let's start with NaCl. So the Cl is what I would find on the chart here. And Na is not listed as one of the exceptions, so therefore this would be soluble. So for the subscript, I would write AQ for aqueous. And then for the magnesium hydroxide, MgOH, here's the OH. Mg is not listed as one of the exceptions, so therefore it would be insoluble, and therefore we would write it as a S for a solid precipitate. And then later this week, what we're going to do is we're going to continue. This would be called the formula equation, and then you would write the complete ionic equation by disassociating everything that's aqueous. And then you would write the net ionic equation by canceling out any ions that are what we call spectator ions to get your final net ionic equation. And that will be later this week. And again, make sure that you do number 9 on your own.